Hi everyone, welcome to this series, continued series on understanding the data and the pre-processing steps required for machine learning and deep learning. In the previous session, we talked about essentially we are focusing on the numeric data, uh, and in the previous video, we actually talked about the data types and the feature types, and for example, categorical variable, nominal variable, discrete variable, binary, and so on and so forth. And in this video, we're going to talk about the general inspection, the methods available within Python using Pandas, and how to check for duplicates and why do we need to check for duplicates. Essentially, this is the pre-processing, and we're going to cover these two topics, general inspection techniques and the handling of duplicates. So let's take a look at general inspection of data. What are the methods available and why do we need to do so? It is actually for preliminary assessment or understanding of the data, just to identify if there are any initial issues with the data, like inconsistencies or data with a timeliness, time issue, or any pattern which can affect the analysis of our data. Gain the understanding of data quality in terms of distribution, or if there are any potential challenges before we proceed with the machine learning modeling. So general inspection typically is a beginning or starting point before we do any decision on data cleaning, transformation, or even pick and choose a particular model. So let's talk about what is general inspection in terms of these steps. We might be interested in knowing the number of rows and number of columns in the data. What are the data types in the data set, numeric, categorical, ordinal, discrete, and how many samples are available? How many samples or rows for each of the categorical values, and so on and so forth. We will discuss why it is important to analyze or focus more on categorical variable as well as numerical variable. But categorical variables pose more challenges than numeric variables when it comes to machine learning. We'll apply basic statistics like mean, median, mode on the dataset. We'll also get a preliminary understanding of the number of rows, a number of columns missing, or the number of places in the column the values are missing, because machine learning models cannot work with columns having no values in there. And we will also look at data distribution in terms of histogram, or it could be scatter plot, or we might want to use bar plots. General inspection for data quality. So some of the techniques can be a little difficult. For example, finding out the consistency of data. So how do we look for data consistency? Some of the simpler techniques can be formatting. I mean, and if the alphanumeric column has a decimal value, or alpha column has numeric value, and so on and so forth. Number of unique values in a column also is quite a significant determinant in terms of the model quality that we will end up with. High number of unique values or low number of unique values, both of them are problem cases. Domain knowledge is quite important. As we discussed the nominal and ordinal scale, so for example, let's say you are expecting the value to be GE in a particular column, but you have similar representations in the rest of the other places, and this is not acceptable. So then we have, for all the columns which are categorical in nature, we have to make sure the values are standard that we expect. Sometimes the numeric variables may contain alpha numeric values, that is also not desirable. So we need to look for such patterns. Now, timeliness of data, how up to date are the observations in the data? If we expect the data for the last 12 months, then we must make sure the data belongs to that period only. And data collected over time also has an issue. For example, let's say we have cost of production field, and certain value 3 years ago was cost of production maybe like 100 rupee and or $100 or whatever, and now same job or same work is now $500 or 500 rupee. Now either the case, this is going to be problematic when we build our machine learning models or some analysis. So in such cases we have to figure out a way to normalize, and such normalization typically requires strong domain knowledge. Handling duplicate data or duplicate rows or partial duplicates is also very significant. Practically, you will not have too many rows being duplicate in your data set unless our data engineering or data assimilation or data ingestion process is not up to the mark. Um, so then in that case, we will need to detect the duplicate rows, either complete row being duplicate or partially duplicate. Some of the examples of data set where the duplicate data can be problematic, like customer data set or clinical trials data, social media engagement data, or sensor data. In fact, the duplicate data can be problematic in almost all cases. So what are the steps we need to identify the duplicates in terms of complete row, or it can be partial duplicate? And deduplication process typically involves domain consultation. And then sometimes we may have to go for or implement some advanced matching techniques to determine if the duplications actually exist. And this process of deduplication and finding the duplicates is typically iterative in nature. So that means there could be multiple cycles. Let's take a look at a simple demo using Python pandas, and I'll walk you through some of the typical steps that are possible with pandas. How to check for general sanity in terms of duplicates and this data distribution. Here's a little example here. Let's go through this, and this is having iris data. And once you load the data here, you can take a look at the first few rows or last few, or you could do a sample. Ideally, you should do a sample so that you get to know if there are any problems with the column values. Summary statistics. This is the basic statistics on numeric column. Let me walk you through what we actually should look for in such output. So this pandas describe method provides you the basic statistics here. The last column is categorical in nature, and this one is essentially the values like 0, 1, and 2 because there are three classes. So this statistic for this column really does not make much of a sense. But the other column, like sepal length, sepal width, petal length, and they are numeric. And what we see here, the mean value is 5. So if you're a domain expert, you can verify whether 5.8 really makes sense or 3.0 makes sense in terms of a mean value or a general value in the column. And likewise, standard deviation, whether it matches your expectations, since you are a domain expert and you have an idea, the standard deviation of these columns should be something, and if they are not around what you expect, then there is a data quality issue. Then you look for the minimum value and the maximum value here. So the distribution, 25th percentile, 50th percentile, and 75th percentile. And that gives you a very good understanding of how the values are distributed in the column. And since all of this thing actually requires a very strong domain understanding to match the output with the expectations here. So this is quite important, summary statistic from Pandas. Let's look at the missing value. Quite easy. Pandas provides the is null method, and you can find out how many places in the columns we have null values. Here, there are no null values here, which is perfect. Duplicates also, Pandas provides the complete row duplicate, and then I'm going to show you how to also identify partial duplicates. Unique values in the target variable. So we have only one categorical variable, which is a target here. So this essentially means there are 50 samples for each of the classes, which is perfectly okay. Then some distribution is important, as you see here, sepal and how the for each of the class. Let's analyze what's happening here for sepal length. The distribution of data for class 0, class 1, and 2. So what are we actually looking at? We want some kind of separation in the distribution of data for that particular column. For example, this one can be a problem here because the values for all the both the classes are same, which is not really good for machine learning. Let's look at some more intuition. For example, this scatter plot that you have here, which is giving you a sense of distribution of data, sepal length versus one column here. Then here the distribution is quite, distinct, which is actually good for machine learning. So this initial understanding of the distribution of data can lead to decision making for the amount of processing that we have to do, or how good is the data quality at the first sight. So likewise, we need to analyze for all the columns here, and this iris data is actually very good, has been curated properly, and you see here the distributions are quite well separated. And if they are separated, that's actually wonderful for machine learning. And the box plot also talks about for each of the column, let's say sepal length, sepal width, petal length, and petal width, the values are quite separate from each other, which is also very desirable for machine learning. Let's look at another data set here, this time breast cancer data set from scikit-learn again. So this has all the numeric column except the last one, which is a target categorical column. And this data set is about patient having cancer, and 0 and 1 is the classes here. So first thing, the info will tell you the information about the data in the data frame. The useful thing that we can derive from the output is, let's look at the number of entries, 569. Here the number of entries 569 are not null. That means there are no null values, and you can clearly see there are no null values. So this is quite good. You also get to see what type of data that you have, float, which is again quite good for machine learning. And categorical data will be represented differently, with the value under this column would be called object. So again, the describe here will give you the basic statistics on each of the column, and this requires domain understanding, whether the standard deviation or the mean or minimum or the distribution of data as per the quartile, 25th, 50th, 75th, and maximum, whether they are as per the expectations or not. This typically requires a very intense manual observation. You can automate this process as well. I mean, we can certainly automate using some programming techniques to see if there are any deviations in the data compared to the set expectations. Number of unique values in the target. Here we have 357 rows for a class of 1, 212 rows for class of 0, which is fairly okay. Data is well distributed. Missing values, there are no missing values here. And the box plot representation, again, I mean, if you do a box plot of all the column in single plot, that won't look nice because the values are quite vary from each other, and that's why the this plot does not give you much of information. So what you should do, you can take one column at a time and then analyze the box plot. So let's take a look at least one of them here. Let's say the mean concavity or something, and let's say this is at class of 0, class of 1, and you can see the data is quite separate, which is very nice for machine learning. Here can be a little problem because the data is not very distributed. Here it is pretty okay. Here also can be problematic. Well, I mean, in machine learning, you cannot expect 100%, discrimination in the data to exist. There would be some problem, but by and large, we need to look at the data whether it allows for a decent machine learning modeling or not. So again, the data distribution here, if you look at the data distribution of the column, let's say the mean smoothness here, the distribution looks the same for both the classes, which is again not something that we look for. But then the other column helps here. The distribution of data is quite shifted from each other, which is good. For example, here also is quite shifted, which is again desirable. So again, by and large, as I mentioned earlier, so we look at the all the possible plots and just make a subjective decision whether we have discrimination in the data. Discrimination in the data is important part in machine learning. If we don't have discrimination in the data, it's hard to build a machine learning model. So that was an example of how we check for sanity in the data. And similarly, how to check the duplicates, quite easy. I mean, let's say you have these data and here the duplicate values are the Anand and Singapore. There's another Anand and Singapore here. So if you have that data and then ask the data frame to tell you whether you have duplicates or not. So it's going to return a row marking true, that means duplicate. Pandas also lets you keep the last and first. That means it will show the last one as a duplicate, not the first one, and vice versa. Duplicated method is going to return you the index, and those indexes you can pass to the data frame to see which rows are actually duplicate, and here are the rows which are duplicate. In real projects, you're going to look at the row and analyze, what would be the next step. Finding the complete row duplicate is rarely the requirement, but duplicate based on selected columns would be something that requires domain and business sense. So Pandas provides you that. Let's say by name, you want to find out if there are any duplicates here. So apply the duplicated based on the name. Are there any duplicates? If there are, then it's going to return you those. And similarly, you can make a decision to drop the duplicate rows here in the code, or you could make a decision to drop rows and column as part of another project, after you have finished all these steps in the pre-processing. So that's it here in terms of the sanity checking of the data. So we talked about general inspection of data using pandas, and also we looked at how to identify duplicates using pandas. In the next video, we'll talk about the missing value treatment, and this is quite interesting and quite important topic. And see you in the next session.